All right, let's dive into something that is absolutely fundamental for anyone who uses data to make decisions. And that's the question, how do you really know if you can trust your data? We're going to dig into a really powerful tool called Gage R&R, which is, honestly, the key to building that trust. So let me just kick this off with a big question for you. What if that problem you're trying so hard to fix, what if it has nothing to do with your process and everything to do with the very ruler you're using to measure it? You'd be surprised how often this happens, and believe me, it's an incredibly costly mistake. I mean, just picture it. Your team is spending countless hours, a ton of money, trying to fix a manufacturing process. You're tweaking machines, you're retraining people, and you're getting nowhere. Why? Because the process was perfectly fine all along. The real villain of the story? Bad data, coming from a measurement system you just couldn't rely on. So, to get to the bottom of this, we're going to follow a really clear diagnostic path, kind of like a consultant's toolkit. First, we'll figure out if your data is lying to you. Then we're going to break down exactly what measurement variation is. After that, we'll look at how you pick the right R&R study for your situation, how you actually do the analysis, and, this is the most important part, how you make sense of the results. And we'll even touch on what to do when you're not dealing with nice, clean numbers. Okay, so first things first, let's talk about the business case. Why should you care so much about measurement error? Well, it's simple. Bad measurements lead to bad decisions, and bad decisions, they cost a lot of money. We're talking about wasted materials, unnecessary downtime, maybe even shipping bad products out the door. It's serious stuff. I mean, this quote really says it all, doesn't it? It perfectly captures this nightmare scenario where a team is just chasing a ghost in their process. They're throwing resources at a problem that literally doesn't exist, all because they put their faith in faulty data. A simple check of their measurement system up front would have saved them time, money, and a whole lot of frustration. Now, the discipline that stops this from happening is called Measurement System Analysis, or MSA. You can think of it like quality control, but not for your product. It's a quality check for your measurement tools. And Gage R&R is one of the absolute best techniques in that MSA toolkit. So, if we're going to understand our measurement system, we need to break down where the errors can come from. Turns out all the variation, all that noise in your measurement system, it really boils down to two main sources: repeatability and reproducibility. This is a fantastic way to think about it, because it separates the tool from the people. Let's use an analogy. Repeatability is all about the equipment. If you step on your bathroom scale 3 times in a row, does it give you the exact same number every time? That's repeatability. Now, reproducibility, that's about the people. If you and your friend both use that same scale, do you both read the number the same way? That's reproducibility. You've got to have both for a system to be reliable. And hey, when we say the word gauge, please don't just picture some old-school physical tool. In the world of MSA, a gauge is anything that gives you a measurement. Yeah, it could be a pair of calipers, but it could also be a multi-million-dollar machine or even a piece of software that analyzes an image. The principles we're talking about here, they're totally universal. Okay, so we know we need to analyze our measurement system, but how do we do it? Not every situation is the same, which means we need to pick the right diagnostic tool for the job. And there are a few different flavors of Gage R&R studies to pick from. This table here lays it out pretty clearly. The most common one you'll see is a crossed study. That's where every person can measure every single part multiple times. It's great. But what if testing the part destroys it, like a crash test for a car? You can't have a second person measure the same wrecked car. For that, you'd use a nested study. And for really complex situations, you might use an expanded study to bring in other variables, like different locations or different labs. Now we get to the how-to. Once you've picked your study type and you've got your data, you have to analyze it. And while there are a few ways to do this, the absolute gold standard, the most accurate and widely used approach, is called the analysis of variance, or just ANOVA. Sure, the other methods can be okay for a quick look, but ANOVA is way more powerful. Its real superpower is its ability to find and measure the interaction between the people and the parts. What does that mean? It can tell you if, say, one of your operators has a really hard time measuring a specific type of part. That's a level of detail the other methods just can't give you. Now listen, setting up the study the right way is absolutely critical. You can't just wing it. You need a good sample of parts, at least 10, that really represent the full range of what you normally see. You'll need 2 or 3 operators, and they'll each measure every part a few times. But the secret sauce, the thing that makes it all work, is step 4. You have to randomize the order. That stops people from just remembering their last measurement and writing it down again. It keeps the data honest. Look, you don't have to be a statistician to get what ANOVA is doing. The goal is actually really simple to understand. It takes all the messiness, all the variation in your data, and it neatly sorts it into different buckets. It tells you how much variation is just because the parts are different, how much is from the gauge itself, how much is from the different operators, and how much is from that tricky interaction we talked about. It basically gives you a perfect map of where your measurement error is hiding. And that brings us to the most important part of this whole thing, getting the verdict. You've run the numbers, so what? What do they actually mean? Is your measurement system good to go, or does it need a major overhaul? Thankfully, we don't have to guess. The Automotive Industry Action Group, or AIG, created these super clear stoplight-style guidelines that pretty much everyone uses. The big number you look at is the percent gauge R&R. It tells you what percentage of all the variation you're seeing is just noise from your measurement system. If it's under 10%, you're in the green. You're good. Over 30% is a big red flag. And that yellow zone in the middle, well, that's where you have to use some business judgment. So in the example from our source material, the result was 18.71%, and that lands it squarely in that yellow "it depends" zone. It's not a total disaster, but it's not great either. A result like this forces you to make a decision. Is it worth the cost and effort to improve the system? If it's for a non-critical feature, maybe you can live with it. But if this is a critical safety component, 18.71% might be way too risky. But wait, there's another number you have to look at, the number of distinct categories, or NDC. This answers a totally different but just as important question. It basically asks, is my ruler sensitive enough? Can it actually see the tiny differences between parts that I really care about? In our source example, the NDC came out to be 7. So, what do you think? Is that good? Is it bad? Well, here's what that number means. The industry standard says you need an NDC of 5 or more for a system to be considered adequate. So our result of 7? That's good news. It tells us that even with that 18% noise we found earlier, our system is still sensitive enough to reliably tell the difference between at least 7 different groups of parts. If you get an NDC of 2 or less, it means your fancy expensive gauge is basically just a coin flip, a simple go-no-go check. So far, everything we've talked about has been for measuring things on a continuous scale, with numbers. But what about all those times when the measurement is just a judgment call? A simple pass or fail, or a cosmetic check for good versus bad. Human judgment is a measurement system too, and you better believe it needs to be checked. For those kinds of situations, we use something called an attribute gauge R&R. Instead of looking at variation in numbers, it measures how well your inspectors agree with each other. The questions we're asking are our inspectors consistent with themselves, and are they consistent with each other? The process itself is pretty straightforward. You start with an expert, a master appraiser who sets the correct answer for a bunch of sample parts. Then, your real operators inspect those same parts, usually a few times each. From there, you can calculate their repeatability, how often they agree with themselves, and their reproducibility, how often they agree with each other. And finally, you see how well they all agree with that expert standard. The goal here is pretty high. You're usually shooting for over 90% agreement across the board. So we end up right back where we started. By using tools like Gage R&R, you're not just blindly collecting data anymore. You are actively ensuring its integrity. You're making the leap from uncertainty to real data-driven confidence. And that leaves us with one final, and I think pretty exciting question. Once you can finally, truly trust your data, what hidden truths about your business are you ready to uncover?